Alright, let's get started with the solutions for exam 5. Well, the first question asks, what is the defect rate in this process? The easier way to do this is, instead of defect, if I had asked you yield, it would be pretty easy, right? If I had asked you yield instead, then we have a scenario when to be a good product, everybody has to do it right. If everybody has to do it right, the yield is just a multiplication of all the yields. 95 times 0.85 times 0.95 times 0.90, which comes out to be about 0.5178. Well, but that's not what the question is asking. The question is asking defect. Well, defect is nothing but 1 minus yield, making this 1 minus 0.5178. So the defect rate is 0.4872. That is your defect rate. Alright, the next question is food served at a restaurant should be between 38 and 49 when it's delivered to the customer. This process has a standard deviation of 32. What is its CP? CP is USL minus LSL, upper specification minus lower specification, divided by 6 sigma. Well, upper specification is 49, lower specification is 38, 6 times 2, so 11 times 12. So a little less than 1. The next question is, well, it's a little less than 1, so I want, say, CP to be 1. Then what should be my standard deviation? Obviously the standard deviation should decrease by how much? Well, I want the CP to be 1, so CP upper specification limit minus lower specification limit 6 sigma. So I want to find this, what's the value of sigma? Well, cross multiplication 6 sigma equals to 11, or sigma equals to 11 divided by 6 comes out to be about 1.833. Alright, the next question asks you, what percentage of the food delivered to the customers are between desired temperature? Well, remember, the thing that the machine that gives the temperature has a mean of 33 and a standard deviation of 2, but we want the temperature between 38 and 49. What percentage lies in between? Okay, let's draw another normal distribution with a mean of 0 and a standard deviation of 1. Let's find the equivalent of 38 and let's find the equivalent of 49. The equivalent of 38, let's call it G1. Equivalent of 49, let's call it G2. Z1 is nothing but 38 minus 33 divided by the standard deviation of 2. So 5 divided by 2 equals 2.5. Z2 equals to 49 minus 33 divided by 2. So 16 divided by 2 equals to 8. Well, the Z equivalent of 2.5 is, Z of 2.5 is, this comes out to be, so this value comes out to be 0.9938 from the table. You don't have a Z equivalent of 8 in the table. The reason it's not that it's so far out that it's almost 100%, so call this 1. So we have about 0.0062, that is only 0.62% of the food that is brought out is within the required temperature. Alright, the next question asks you what is N? Well, remember, N is the number of items in the sample. So each sample, the first sample is taken at 10 a.m. on the day 1. It has 17, 13, and 6. So that means N has to be 3. Well, the next question asks you to fill up the X bar. Well, X bar is nothing but the mean of the x's. So 10 plus so 10 plus 18 plus 17 divided by 3 comes out to be 15. Similarly, the R bar is the max minus mean. The max is 18, mean is 10, so this is 8. So next question asks you what is the x bar bar and R bar. Well, x bar bar is the mean of all x bars 12, 17, 16, 14, 18 and 15, and R bar is the mean of all the 11, 12, 9, 5, 6 and 8. I'll leave the calculation for you. It comes out to be 15.33 for the x bar bar and 8.5 for the R bar. So this is x bar bar, this is R bar. Well, make the x bar and R bar charts. To make the x bar charts, alright, we need 3 values. To make the R bar charts, so this is x bar, this is x bar, and R. The x bar, the central line is just the x bar bar, which is, we calculated 15.33. For the R chart, the central line is the R bar, which is 8.5. Well, now next question is what is the upper line and what is the value of the lower line? Well, the value of the upper line is x bar bar plus a2 R bar. Well, we already figured out n equals to 3. The equivalent of n equals to 3 for a2 is 1.02. So this is just 15.33 plus 1.02 times the value R bar is 8.5, comes out to be 24. This is x bar bar minus 1.02 times 8.5 comes out to be about 6.66. The R bar is nothing but D4 R bar, and this is D3 R bar. If you look at the table, D4 for n equals to 3 is 2.57, and D3 for n equals to 3 is 0. So D4 R bar is 2.57 times 8.5, and this is 0 times 8.5, comes out to be 0. So this is 0. This comes out to be 21.845. Now the next question asks you to plot the readings from the second day and comment if the process control or not. So we need to plot the values here. So the second day starts at this reading. So the mean x bar is 14 and the R is 5. So we have to plot 14 and 5 respectively. So 14 is somewhere here. We use a different color here. So 14 is somewhere here. The R was 5, so 5 is somewhere here. So the next reading is 18 and 6. 8, so this was 14 and this was 5. 18 is somewhere here, and 6 is somewhere here. So it's kind of good to draw the line. And the third reading was, we calculated 15 and 8. The x bar was 15, so the 15 is somewhere here. The R bar is 8, so it's somewhere here. So the next question is the process in control or not? Well, the process is probably in control, but there is something to worry about, something to keep an eye on, because the R is in the same range. Again, as I said, this is usually not an issue. If you see this kind of behavior in here, that is a concern. If you see a behavior like this in the R, it's not as much of a concern, like 3 points in the same side. It's okay, but it's something you have to, it's not as serious as this, but it's still something you have to keep your eye on. All right, that's all there is.